Hi, my name is Sloan Smith, and this is Experiment 2 for Physics 2212, Magnetic Fields. The purpose of this experiment was to explore magnetic fields from a bar magnet and how it interacts with the Earth's magnetic field. Furthermore, we wanted to see how magnetic fields act when their behavior is not on axis or perpendicular to an axis. Basically, when we cannot describe it as one of the equations for those two situations. One of the principles we used was that magnetic bars are magnetic dipoles. We also used the magnetic dipole calculations, which can be derived from Biot-Savart's law for currents. For the magnetic dipole, we used the equation that B is equal to mu naught over 4 pi times 1 over r cubed times 3 mu times, dot product with r hat times r hat minus the vector mu. For graphing, this can be represented as the natural log of b is equal to the natural log of k plus the natural log of r to the n power, which can be simplified to n times the natural log of r. The result we found was that the magnetic field was observed to approach zero when the magnet was far away and increased in magnitude as the magnet was brought closer. Using a magnometer, we found the magnetic field of a point that was not on a parallel or perpendicular axis. For this experiment, the system was the magnometer inside the smartphone. The surroundings were the magnet and the pieces of marked tape used to measure distance. In order to find the n value for r, we took distance measurements at places where the magnetic field was 20 microtesla, 70, 120, 170, and 220 microtesla. In order to find the n value for r, we took the distances and b values and plotted the natural log of b versus the natural log of r to get a line of best fit. Since in the equation n multiplies by the natural log of r, we knew that the slope of the line gives us the n value. We found an n value of negative 1.78. However, in theory, the n value should be negative 3 because in the equation it is 1 over r cubed, or r to the negative third power. We also saw that mu was equal to 5.25 amperes meter squared. Then, using the marked tape to measure, we set the magnetometer a distance of about d is equal to 18 centimeters from the magnet in both the horizontal and vertical directions. Then we used the magnetometer to find the magnitude of the magnetic field at the location. We found an observed B field of 1.26 times 10 to the negative 5th Tesla. The data to the right are the data shown from DPerp, both before and after adjusting for the Earth's magnetic field. We used the equation from Biot-Savart's law in order to base the code off of. First, we created a function to find the magnetic field at any location. Then, we used that function to calculate magnetic fields at points on the axis and on the perpendicular axis, which could be checked manually. Finally, we used the function to calculate the magnetic field at the location DD0, which is an x location of D and a y location of D, and a 0 in the z direction. The computed magnitude of the field was 5.03 times 10 to the negative 5th Tesla. In the coding picture, you can see the written code for how to find the magnetic field at any location. From the computed and observed B values, we see that the computed was almost 5 times the magnitude of the observed. But both results are in the same order of magnitude, and when you break them down into component forms, all components are in the same directions, except for the observed z component, which was predicted as 0. The sources of error include not accounting for the Earth's magnetic field in the computer code, nor accounting for any z-axis difference due to the depth of the phone. Also, my phone had a tendency to give wildly incorrect net fields with no magnetic effect affecting it until I shook it, which could suggest an error within the phone. Finally, the what-if questions. What if we had not compensated for the Earth's magnetic north? If we had used a random angle instead of aligning the phone so that the phone pointed north, we would have had to adjust the x component of the observed fields to calculate out the effect of Earth's field. Otherwise, we would be getting numbers that are incorrect for our magnet. And if we had used two magnets on top of each other, two identical magnets on top of each other would have their poles aligned. Therefore, they would act as one singular, stronger magnet. The magnetic fields observed would have their magnitudes doubled. Thank you so much.